Hello and welcome to our webinar with the title Building Security in DevOps with Intelligent Orchestration in cooperation with our partner Synopsys. I'm Sarah from we.CONECT and I'm very happy to welcome all participants today and of course also especially our speaker Meera Rao. Meera is Senior Director of Product Management at Synopsys. And yeah, if you have any questions during the webinar, please enter them into our questions tab in your GoToWebinar control panel. And there will be a Q&A session after the presentation where we will take the time to answer all your questions. That was already all from me for now, and I'm very happy to hand over to Meera.
Thank you, Sarah. Hello, everyone. Good morning, good afternoon. Like Sarah mentioned, my name is Meera Rao. I've been working with Synopsys for 14 years now. Yes, a long time. So today, again, like we saw in the first slide, we are going to talk about intelligent DevSecOps pipelines. So we all know that automation is key for DevSecOps. Bringing in one or more security tools, right? Application security tools, whether it is for SAST, software composition analysis, DAST or IAST, automating that within your CI/CD pipelines isn't going to cut, right? We know that that's not going to work, that there are so many challenges about that. So at Synopsys, we have built an amazing innovation, right? And then yes, we have patented this intelligent DevSecOps pipelines, and that's what I'm going to talk to all about today, right? So what are some of the challenges that we see? How did we overcome these challenges? What are some of the ways that we overcome the challenges that we see in all categories, right? Like people, process, and technology. My goal and role within Synopsys is to build products that help our customers to scale using our application security testing tools, and then to also innovate new solutions which will solve problems for our clients, right? So again, like I said, the goal is to show you how do we build security in DevOps with intelligent orchestration. We call it as IO. And then how can we help you maintain the speed and scale throughout your SDLC, right? Because at the end of the day, the goal of any organization is to go to the customers or go to market with new solutions day in and day out, right? And that's what we're going to focus on today. Like, without compromising security, how are you going to do all of the activities that you are supposed to do, right? With that said, I'm going to switch off my camera and then turn it on back so that it doesn't distract. So let's get into the challenges, right? So more of everything. We see this often, like modern software development is more of everything. You have more code, you have more complexity, you have more languages being built on many different platforms, and then you have so many deployment options, right? So anytime I talk to my customers, some say we want everything on-prem, some clients say we want some in the cloud, we want some on-prem, some are like we want things to work on different platforms, right? So the more and more, and then at the end of the day, all of them want more velocity, right? So no matter what, whether we are deploying it in on-prem or whether we are deploying it in the cloud, we want to maximize the velocity and then provide that continuous improvement throughout this process to the development team to the operations teams as well as the security team. So as you talk about more code, more complexity, more velocity, this also means more risk. So even if I look at the 14 years that I have spent in this industry, application security industry, I see a lot of different new risks that have come up lately than when I started, right? So the more code, more complexity means more places where things can go wrong. And then more velocity means you have less time to focus on application security, right? Because you're deploying every single day and then you have less time. So, and then the next thing we see is, as we are looking at all of those more of everything, the next thing you see in the industry is DevOps, right? So in working with, like, over the past 14 years, like so many customers, number of security and development teams, one of the biggest challenge we see is the wide range of problems when it comes to security, right? Across all the industries, the goal is they want to follow cloud, they want to use cloud, they want to follow DevOps, and at the same time, they want to manage the risk, right? So you want to deploy to cloud. So when you say I want to deploy to cloud, you need to build solutions that work in the cloud. So what does it mean? It means like you need to make sure that you are able to deploy those applications in containers. They are microservices, single page applications. They have APIs. They need to be cloud agnostic, right? It doesn't matter whether I deploy it in GCP, AWS, or Azure, it needs to work. And then, so if you want to do all of these, then you need to adopt the DevOps culture, right? So when we talk about DevOps culture, again, it's about how do I automate, how do I orchestrate all of these tools, how do I bring all of the processes that I have, right? Processes that I have, whether it is governance, compliance, risk management, or any policy, how do I bring that into my DevOps culture, right? And on top of that, right, when you're doing all of this, when you're adopting cloud, when you're adopting the DevOps culture, how do I manage risk, right? There's a lot of pressure. There's a lot of different security activities that find different things, right? No one tool finds everything that you want to find. How do I correlate all of this? And then how do I prioritize, right? Risk management is all about prioritization. How do I do that, right? So again, when we talk about risk management, when we talk about testing, so we see this diagram, right? This is being part of Synopsys from so many years. So organizations in the beginning, right, in the very beginning, most of the organizations performed all of these activities at the end of the SDLC, all the way at the right, whether it was penetration testing, whether even it was manual code review, right? I myself have done code review for millions of lines of application all the way at the end of the SDLC, right? And then how much time do they give? Like, you would assume that, hey, she's doing a code review for millions of lines of code, so they would give her like 8 weeks. No, right? Like 3 or 4 weeks maximum. How can you find all the bugs if doing a manual code review or even a penetration test when you have limited time, right? No. So the shift left moment started. A lot of activities were being pushed at the were being done way early in the SDLC, like SAST, SCA. That didn't help. They were like, okay, we are going to put all of these tools in the hands of the developers, let them run static analysis, let them run software composition analysis, and at that point we forgot that we need to configure the rules, right? So you gave the tool to the developers, and these tools took so many minutes or in some cases hours, right? And then it used to bring your IDE to a grinding halt. Developers decided, okay, we're not going to use these tools, right? So from the planning phase all the way when your code goes to production, we saw challenges after challenges after challenges, right? And then even when you automate all of these things, there are only certain things that your automated tools can find. They cannot find flaws, right? You still need to do threat modeling. You still need to do architecture risk analysis, right? You cannot automate a penetration test. Yeah, you can automate a DAS tool. You can automate an IaaS tool, but a human being performing penetration test is way more targeted than using either a DAS or an IaaS tool, right? So you need to balance. So again, that was the biggest challenge. How do we balance automated activities versus manual activities? How do we prioritize all the results that you get from all of these activities that you do in your SDLC? And then how do you continuously like go to market when you have so many activities to perform? Right? So yes, testing requires multiple tools, requires multiple activities, requires multiple artifacts that are needed, but then it also requires multiple ways to look at those findings that you find from all of these and prioritization, right? So the next thing, again, one of the key things we saw when we started preaching that you need to do all of these activities, yeah, there were a lot of customers who did all of those activities. Like we are talking about so many tools in different stages of the pipeline, right? So when the code is being built, we want to do static analysis. When you have the code built, you have the binaries that you want for the code. Then you say, okay, do software composition analysis. Your code is able to be deployed in some form or shape. You want to do DAST or IAST. Okay, you're deploying it on a container, then yes, hey, go ahead and do container analysis, right? Okay, you're deploying it on a virtual machine. Maybe we want to do some network related test, right? You're going to deploy to cloud. We want to do a cloud configuration. So at different stages, we started coming up with different activities, and no one tool can do all those activities. So we started coming up with different tools, right? And then the pipelines also vary based on the technology stacks. I cannot use the same tool. Yeah, if a tool supports all the languages, all the frameworks, all the technologies, yes, I can use it. But in many cases, the tool vendors need time to support your new language, your new framework, right? Until then, what do we do, right? And the mindset of all the tool vendors is we try to find more, right? Because that is when we can show value for you. Yeah, we try to make sure that we have less false positives, but then the goal is to find more vulnerabilities. Yes, we do categorize critical, high, medium, low, informational, but then do you have to look at all of those? Again, that is where we want to make sure that we talk about those things in this webinar, right? How do you prioritize? And there is no way to provide continuous feedback. There's one tool which provides feedback in one way, maybe a PDF or a JSON or a Word document or an Excel spreadsheet. Like each and every activity that you do, each and every activity tool that you bring has its own way of providing you the feedback, right? Whether you want to break the build, whether you want to send notifications, whether you want to create defect tracking tickets, right? And then scaling now remains a challenge, right? When you have so many tools, imagine how much infrastructure you need in order to perform all of these activities, right? So when I say infrastructure, whether you're doing it in the cloud or in-house, you have to pay for all of that, right? So scaling to the level that where you want to run all of these activities needs a lot of infrastructure, right? So some of the challenges that we saw, what are some of the challenges that we see as teams started moving towards DevSecOps, right? Where do we start? Like all of the companies that I talk to either have open source or commercial tools, right? So is it sufficient for me to just get this tool and automate in the pipeline? No, right? Is there more to it? Yeah, there is. How do we ensure that our application security practices keep up with the pace of development? Right now, like if, say for example, if you have listened to all the webinars that I have done over the years, all of the white papers that I have written, the blogs that I write, how do you maintain the velocity? By doing all of the activities that we talked about right now, right? Because each and every activity takes time. So if your development team has made a change, like simple change for some font in a JavaScript file or some minor change, right? And we tell them, no, this change needs to go through all the security activities. You cannot keep pace with them because your activities take long time. How do we maintain visibility, right? Like I said, there are activities which are automated, there are activities which are manual. Each and every activity provides you like so much information. How do you sift through all of that information and then provide the one that is truly needed for the developers to fix? For your executives, right? Okay, what is the risk of this application at the end of the day? How are you able to provide that information where your stakeholders are aware of the security of that application, right? And then again, the challenge here is how do we shift left, right? We have so many policies, we have so many procedures that we need to follow, so many compliance requirements. You cannot rely on the developers, right? Because the goal of having top-notch developers is to push code to production and then new features, right? You cannot make them security experts. You can, but then that's not their job. They are doing a different type of work, and now we are asking them, on top of everything that you do in order to build this amazing application, you're also responsible for security. So you need to know what policies, what standards, and everything else, right? That's not going to work, and it never worked. So one of the key things that I ask when I talk to my customers is, where do you want to go next? What do you want to do, right? Are you able to, I never ask that, are you able to automate your security tools, right? Anyone can do that. You can bring in a tool, automate it in a CI/CD pipeline. You don't need me helping you do that, right? So one of the key things we ask is, are you able to automate decisions, right? So when security activities are needed and when they are not needed, right? Not always do you need all of the activities to be performed that we showed in that slide. Are you able to identify when manual activities are needed, right? So there needs to be a balance. When do I do all these automated activities versus when do I not do those and then do like a manual code review, like a manual penetration test, do a update to my threat model or perform a risk analysis, right? Do you know that? When do you need to do that? Not every release you cannot do that, because all of those activities cost time and they cost dollars. And the next thing is, how are you able to automate all your governance compliance needs? A lot of organizations that I talk to have compliance needs that every 90 days, no matter what the kind of release is going to production, you need to do a manual penetration test. Every 6 months, you need to do a manual code review on top of the automated SaaS that you run. So do you have like a spreadsheet and some alert somewhere that alerts you, hey, it's time for penetration test, it's time for a manual code review? You should be able to automate that decision in your pipeline. Yes, 90 days is over. Not at the 90th day, like few days before that 90 days, hey, you need to now trigger a manual penetration test. You need, because again, most organizations do outsource penetration testing, right? So all of those manual code review. And are your tools meeting your needs, right? Have you configured those? Are they actually finding the things that you want to find? And then how are you providing this feedback back to your developers? Are you giving all the results that the tool finds to your developers? It's going to frustrate them to the core, right? Because they're like, what am I going to do with these thousands of issues that you gave me? I'm not going to fix all of these because my responsibility is to provide you new functionality, right? Yes, my responsibility also is to write good code, secure code, but then you're asking me to fix thousands of issues. They'll come up with a level of effort saying this is going to take 1 year, right? We cannot do that. So as and when we find vulnerabilities that are crucial for the application, for your business, then you need to let them know so that they can fix those then and there, right?
Mira,
So
excuse
yes.
me, can I jump in for a second to start the first poll?
Oh
Or are
yes,
you,
yes.
yeah, do you want to implement it still, or
Yeah,
yeah,
no. Yes,
okay,
please,
great.
please.
Okay, I'm gonna start it.
Yes. Okay, so here we have a poll, which is very interesting. How frequently do you deploy to production, right? Because based off of this, the ideal solution, I think this is the perfect place for this poll. The ideal solution will change, right? Because there is no one size fits all. So when we come up with all of these blueprints, for our customers, we look at all of these, like how are you going to deploy every single day? Are you going to deploy every 2 days? Whatnot, right? Oh, wow. So every few weeks, yeah. So all of the things that I'm going to show you will work for people who deploy every few weeks, and then even for other people, right? So you can take bits and pieces off of this. Okay, thank you, Sarah. So what would an ideal solution look like, right? So an ideal solution should be able to bring together your people, process, and technology into your pipeline. All of the manual activities that I talked about should be triggered by your CI/CD events, right? So when do I need to do a manual code review? When do I need to do a penetration test? Did my assets change? Do I need to update my threat model? Am I seeing a new API being added? Okay, who do I notify? So all of those should be triggered by your pipeline. And all the rules that you have should enforce themselves in the pipeline, right? Whatever rules you have for compliance, for governance, for risk management, like a lot of organizations have, every critical that is found, the team needs to fix that within 7 days. So now if there is a JIRA ticket created as soon as the critical vulnerability was found, these rules enforce themselves. Part of the ideal solution should now go to JIRA and then say, hey, I see a critical which has exceeded or which is nearing 7 days. I will start notifying the team, right? And then feedback within existing tools. Every critical, like that's what you're seeing here. Again, breaking the build, a very overloaded term that I use, doesn't mean that you completely break the build and start from zero. Whatever is the process in your organization, right? Mark the pipeline as yellow, unstable, right? Send notifications, Slack, HipChat, whatever the team uses. Create JIRA tickets, right? Doesn't mean that you literally break the build and stop the pipeline, right? So give that feedback to the development team and whoever else is responsible, right? And the next thing that we want to do is look at, okay, we looked at all of that. how an ideal solution should look like. How did we come up with that ideal solution within Synopsys, right? So the ideal solution, like I talked about, intelligent orchestration. There is a lot of like Q&A, lot of blogs, lot of articles that I have written about intelligent orchestration. Like I showed earlier, if you follow me on LinkedIn, or just Google intelligent orchestration, you should be able to find a lot of those articles. So here again, the middle block in purple, which is highlighted, is the intelligent orchestration. Here, policy is code, right? So here what we are doing is we are treating security holistically as its own layer that can help you ease your integrations, right? Whether you use all Synopsys tools, you use a combination of Synopsys and open source tools, or you use a combination of Synopsys and commercial tools. This is a completely separate layer, right? So you want your CI/CD pipeline that your development team uses as is, but then you build a second layer, and then through APIs, you can decide how do you trigger all of these activities, either inline and then wait, right? Synchronously or asynchronously. I'm going to trigger, I'm going to continue with my activities, and then at the end of my pipeline, my build pipeline, I'm going to query intelligent orchestration and see, hey, did you find any critical, or some of my policies violated? Did the security gate clear, right? So you can look at all of those, and then the goal here is to make sure that we use the same dashboard that you use for all of your quality findings. We use the same notification systems, we use the same tools that you use, and then come up with a solutions, right? So again, all of you know that Synopsys has a comprehensive portfolio of testing solutions that cover the entire SDLC, right? So we have tools for SAS, software composition analysis, DAST, IAST, a dashboard, right? But then again, it also depends. Not all customers use all of Synopsys tools. So intelligent orchestration works with both, right? So it abstracts and isolates application security testing tools away from the core development pipeline. It provides a very simple API, like literally one line change, to minimize the risk and disruption of any integration within your own pipeline. It runs all the tests without slowing down the pipeline, right? So we want to make sure that we don't slow down your pipeline. It reduces the burden on developers by automating everything, right? And then only providing the issues that they truly care about, right? So they can say, for the month of January, we are going to fix all of the critical and SQL injection. Now, intelligent orchestration will sift through all the findings as the tools run, and then send notifications to the developers when and only when it finds critical and cross-site scripting or SQL injection, right? So, and then it enforces the right test, the right analysis at the right time based on the policy and the risk profile, and then the changes of the code, right? What code changed? How much code did it change? What is the significance of this application? Is it an externally facing application? Does it handle any PII data? Does it have any compliance requirements? And based off of all of that, it comes up with a risk score and decides, okay, I think the change is insignificant. I don't need to run static analysis. I don't need to run software composition analysis or DAST. I can breeze through and push the code to production, right? So it gives the teams the flexibility to adapt the solution to their specific development workflows and then the different tool chains that they use, right? So when I talk about that, one of the key things is to bring in everything as code, right? Everything is managed as code, governance as code. So when you identify gates, how do you enforce them? How do you track them? How do you also have sign-off policies? Yeah, my competitor already has this application deployed in production. I need to push. Yeah, I know there is SQL injection, but I still need to go to production. So you may want someone to sign off on that, right? So it enforces that. And then it also identifies the last bullet there, developers who are checking in insecure code, which is key, right? And then security as code, like I think a lot of you have seen that, especially if you're using Jenkins, shared libraries, or GitHub, GitLab, Bitbucket, CI systems, everything is code there. So even running security tools become part of code. That's what we do there. And then compliance as code, we are also automating all of the policies that you have, right? And then pipeline as code, again, like I mentioned, all of the CI, especially now, everything is in the form of a YAML file, right? So pipeline as code, you can inherit from the base pipeline, add different tools, so you can have a paved road for 90% of your organization, and then you might need this unpaved road for the remaining 10% who are using some technology that no tool has yet supporting, right? So you can do both of those things. And then collaboration as code, right? Because now we are abstracting how the tools talk to the developers, right? So we want to make sure that we provide the same way, right? How do you provide that same kind of feedback for your development team, for your operations team, as well as your security team, right? So everything as code. So what are some of the benefits, right? Okay, we saw that, okay, you're going to make sure that you're enforcing all of the security and risk policies. You showed us governance as code, security as code. Yeah, very good. But what are some of the benefits? What do I get out of this, right? At the end of the day, everyone asks about ROI, return of investment. I spent so much dollars. What did I get out of that, right? So there are 4 key things that we talk about. One is strategy, people, process, technology. I think just yesterday there was a Q&A that I did with the Synopsys where they published this. What is the ROI for doing all of these, right? The very first thing is you're going to find defects early and fix more often. And when you find defects early, you're going to reduce the remediation spend, right? Because we have seen time and again, if you find all these defects way at the end of the SDLC, you're going to spend a lot of dollars, right? And the next thing is you can now prioritize and balance. What are some of the defects that I'm going to fix versus what are some of the defects that I'm not going to fix, right? Then and there itself, you will see the savings, right? Just by the first bullet strategy. Okay, you are not convinced. The next thing is people, right? We help you build those security champions because we have seen that the people, the ratio of the information security team versus the development team is very, very less, right? So you cannot like hire so many security experts. So you build security champions who work within the development teams and they help you reduce triaging time, right? So as and when they see a huge bulk of issues found by a tool, they can go look at those issues and decide, is it a true positive or is it a false positive, right? That reduces communication overhead, like waiting for the information security expert to come into your team, talk to them, explain how to fix the issue, right? So again, you will see some benefits there. Process, right? We are going to optimize testing. Now, when you have to run all the tools all the time, imagine, like we talked about, imagine what infrastructure do you need? Imagine what people, a number of people that you need in order to configure the tools, in order to run the tools, in order to look at the findings, right? So when you optimize testing, I'm only going to run tests that truly are important for every phase in my SDLC, then you're optimizing it. And you're also automating all your manual decisions. Earlier, yeah, you had to wait a long period in order to do a penetration test, manual code review. Now you know when I need to do all of these, and then the pipeline is able to follow that. And then you're able to implement those gates. Yes, all of the organizations want to follow some gates, right? Again, I say like break build for critical and high risk vulnerabilities. Whatever process is in your organization, right? You are able to do that now. Send notifications, don't break the build, whatever, right? And technology itself, now that you have all of these, you're able to measure and tune, right? The goal of DevOps is to fail fast, right? To build that culture of lean and learning. So you will be able to learn a lot, especially when you have all of the other three strategies up and running, right? So now you can fine tune your tools, you can measure, okay, what is the ROI? What was I finding earlier? And how soon am I able to find all of those vulnerabilities now? And then you're able to reduce your defect management overhead, right? Rather than waiting all the way at the end, pushing all those defects to your developers. As soon as they check in, you're able to run, find those critical, and immediately let them know, right? So you don't even have to create a Jira ticket in many cases, right? So you are reducing your defect management overhead. So how do I optimize testing? Let's look at each and every one of these, right? So I talk a lot about pre-commit hooks, which are very key. Again, very, very simple. Look at what are some of the key issues that you're seeing over and over in your project or application, and then make sure some of those, not all of those, some of those are part of your pre-commit, right? Either in the developer's IDE or as soon as they check in, right? And then commit time, again, I always say run incremental SAST with predefined rules. Always gather all the metrics, right? Because you need that. And defect tracking, decide what issues go to my defect tracking. Not all the defects the tool finds should go into your defect tracking, because that has overwhelmed both, right? Your defect tracking as well as your developers. And during the testing time, like the build time checks, again, I call it pre-commit, commit, build, you can call it whatever, right? Automate SAST with comprehensive rule sets, right? You also want to do software composition analysis and any other testing that you want to do. And test, when you already have your staging environment, you may want to do your DAST. Again, I say do a deep dive SAST here with all the comprehensive rules for compliance or whatnot. And then once it goes to pre-prod, right, production-like environment, that is where you may want to do your automate. You may want to automate your hardening checks, right? Like and everywhere you are going to gather all the metrics, automate your defect tracking, and things like that. So let's look at real life examples of how intelligent orchestration has worked in the field, right? So very simple. A small drop shouldn't cause a tidal wave. I gave you the example for this, right? So there was a very small change in a JavaScript file. Again, it was just the font and the color that was changed. Nothing else was changed. And here it was like, you need to run everything. You need to run SAST, SCA, DAST. 2 weeks later, the results were finally reviewed and deployed to production. But then there was a lot of arguments. So what does intelligent orchestration do? It looks at the risk base, configuration settings of the application. It looks at what changes, right? Oh yeah, it's a minor change. Yeah, but then we'll run an incremental SAST, but then we'll skip everything else, right? The code was able to go to production in like minutes, right? So that's what we are showing here, an example of how do I accelerate deployment without compromising security, right? Look at there, SAST is running with Coverity. Again, any other tool that you have will work very well, lightweight. And then look there, build time checks, software composition analysis is disabled, test time again is disabled, right? And then we have the feedback workflow everywhere. And yeah, we are doing a Docker image scan. You can pick and choose all the other activities that you want to do, right? As simple as that. And then when it found sensitive data leak, it paused the pipeline, waits for interactive input, right? Again, it doesn't have to pause. You can decide what process is in your organization and continue with that. Sarah, I think you can do a next poll here. Oh, okay. Which development practices does your team use? Yep, that's very important. What do you all use? I think it's very important. DevOps, DevSecOps. Ah, Agile. Yes. CI/CD. Perfect. Okay, that's good. Okay, let's continue. I also talked about when you have major releases, you need to dig deep into the activities. So if you look here, all of the activities are enabled, like SAST, SCA, DAS. Again, we are using Synopsys tools here, but then you can pick and choose, right? Build failed due to a predefined criteria. What do you want to do, right? It pauses, it sends IM to our Slack channel. And the second real life example is there was a comprehensive change for a crypto API, right? Yeah, the tool, static analysis tool, will find, right? Hey, you used an insecure algorithm, but it doesn't know in the first place, why did you redesign your crypto API, right? So is there any point, like, again, life before was, in this case, they were like, yeah, you need to run all the scans. The tool didn't find anything. So later, a manual review found a wrong control. We needed an encryption while hashing was being used, right? So again, in this case, life after intelligent orchestration, it looks at this, oh, there is a major change, redesign. So it will trigger whatever you want, right? Either a threat modeling or risk analysis, and say, I don't think you need to do any of these other activities, right? You still can do SAST if you can pick that. You can configure what activities to run. So intelligent orchestration might say, okay, I'll still run SAST to make sure that you're using the proper encryption or has hashing algorithms, the proper salt and everything else. But then it knows I need to do something else, right? So again, that's what I'm showing here. The change significance is critical. There was a change in the password functionality. So it's saying, okay, you wanted me to trigger a threat modeling. I'm going to trigger a threat model and pause the pipeline, right? Again, in this case, for demo purposes, we pause the pipeline, but then in real life, whatever you have, if threat modeling, there is a team who does that, it can send email notifications to that. If you want a Jira ticket and then that indirectly goes to the team, it can do that, right? And real life example 3, vulnerability overload, right? This is huge. Every time we run all of the activities, there is huge number of findings from all the tools. And then just looking at all of that, right, takes days. What do I need to do with all of these? So with intelligent orchestration, yeah, you still have all that voluminous list of findings, but then intelligent orchestration knows what are some of the things that the team truly cares about. Yeah, the team doesn't care about like empty catch block, broad exception handling, things like that, but then they truly care about critical and high. Don't let me know anything about medium, low informational findings. it can do that, right? So now you can focus more on important issues that the team cares about, that is risky in having it in your application than all of the thousands of issues that the tool finds, right? And then, like I said, if the pipeline sees something, like we hear it so many times, right? If you see something, say something, right? Everywhere. So it looks at all of the configuration that you have, and then it'll like send notifications. It'll pause. We show all of this in the demo because we want to make sure that when you're saying, I'm going to follow fail fast, DevSecOps, we want to actually fail fast. So show the results, provide real-time feedback, right? Because this is continuous feedback that is part of DevSecOps, right? So again, if you go on Synopsys blog, we publish GitHub actions, and then you actually see that, right? So we showcase, you only see very few alerts, right? So intelligent orchestration integrations for GitHub, GitLab, and Bitbucket will sift through all the findings. You specify in a simple YAML file what are truly the issues that you care about, and in this case, it was SQL injection. So it will only pause, push all the results for SQL injection into the GitHub scanning alerts, but then all the issues are still there in the other dashboards that you use, right? So if you're using we.CONECT, all the other issues are still there in we.CONECT. If you're using Polaris, all the other issues that the tool found are still in Polaris. But then the alerts that are sent to the developers are just the ones that they truly care about at that point in time, so they can go back and fix it, right? So the overload is gone, vulnerability overload. And that's what we are seeing here, tight feedback loops. So we are only showcasing the severity which is high, right? So in this case, they can say, I don't care about individual categories of vulnerabilities. I only care about the severity, critical and high. I don't care about anything else. And then anytime, any tool, right, for that matter, that's why I'm saying it completely abstracts how the tools are configured in your pipeline. So when you configure intelligent orchestration, it knows, it doesn't care whether it's static analysis, software composition analysis, dynamic analysis. You specify the criteria, and then for that criteria, it will pause the pipeline. And again, whatever process you have, break the build, send notifications, create Jira tickets, right? And then here again, we are stopping the build, breaking the, when I say breaking the build, we pause the build, and then we allow to go ahead or completely break, right? Either you can go ahead or abort the pipeline, just to showcase. So what are some of the key takeaways? You saw so many things, right? It's overload of information. There's, like I said earlier, there's a lot of information on what do you call, on Synopsys blogs, other blogs that we have written, talked about intelligent orchestration. Take a look at that. So the key takeaways from this is intelligent orchestration helps you move from a reactive assurance-based model to a proactive model, right? Because now every time any activity, right, it's not just automated activities in the pipeline, even manual activities that you need to do, where earlier you wouldn't have time, you didn't know when to do those, or you were doing it way too much, not seeing any value. Here it's able to focus on that, right? Because it knows, yes, there are major changes, and especially if a organization is continuously doing threat modeling, right? That is where anytime intelligent orchestration is able to see some changes in assets that are being added, new controls that are being added, new attack surface coming into the application, it will be able to pause and trigger those activities, right? And then again, like I said, there is a balance that it will help you strike, right? How much do you find? How much do you fix? And how do you prevent, right? Because now here, since it starts all the way from the time the developer checks in code, you still can have all of the technologies within the developer's IDE, right? You can have plugins for your static analysis tools. You can have plugins for your software composition analysis tools that they run. But the goal here is as soon as the developer checks in code, right? So maybe they develop in their development branch and then they merge to the main branch or production branch, whatever you may call. You may want to run certain activities there to make sure that no new bug was introduced, right? So you're actually preventing, right? Because you are providing input at that instance. You're not even allowing to merge. You're sending it back and asking them to fix those issues then and there. And you're using automation for everything. You saw that governance as code, compliance as code, security as code, pipeline as code, feedback as code, right? So everything that was in your organization, either in SharePoint, in Confluence, in Word documents, in Excel spreadsheet, is now automated and as part of code, right? And then checkpoints. Well, we don't need gates. We want to do all of the checking at the end. Yeah, you can do that. Oh no, we need to have gates after each stage. You can do that, right? Because this is very, very configurable. Where do you want to put the gates? Where do you want to put the checkpoints, right? To see, okay, did static analysis finish? How many findings did it find, right? So the benefit of all of this, the key takeaways is higher speed, right? Because you're not doing all the activities all the time, reduces cost. You saw all of that in the people, in the strategy, in the process. It reduces friction because you're providing this continuous feedback. Your developers know how good their code is. That's what is continuous feedback. And you also have continuous governance because now you know who is the developer who checked in this bad code, how much code was changed, and you can target even training, right? Okay, I want to do a lot of training for this developer because they are checking in a lot of bad code, right? Not to target them for anything else, but target them for training, pair programming, or whatever is the process in your organization, right? So intelligent orchestration helps you address the root cause, right? By building that expertise, because now you're bringing together everyone, providing the right information at the right time, running the right tool at the right time with the right policy, right? Again, one of the things that I did have time to cover in this is it's also able to decide what kind of rules to run, right? So maybe your developer checked in code, bug fixes for SQL injection. It can just trigger to run checks for SQL injection, right? And then not run any other checks because you don't want to waste time. If it is a web application, then the rules that can be configured for the tools maybe was top 10. But then if it is a microservices API, you may want completely different set of rules. So based off of the language, the technology, the framework that you're using, intelligent orchestration can also decide what rules actually apply here in order to run, right? So it can help you prevent bugs from entering the code base, right? And then even if there are bugs which have entered the code base, it can provide you the feedback that is needed at the instance that it happens, right? So Sarah, let's go to the last poll question, and then I can go to the resources slide and then take some questions. Yeah, what security tools do you or your team use? Yeah, DAS, IaaS, SaaS, SCA. So what I have seen in the industry is every customer that I have worked with has tools for SaaS. Maybe like 6 years before, it was only SaaS. And then when that big breach happened for open source component, that is when software composition analysis skyrocketed. So that's what I see. Yep. Oh, okay. Everyone is using SAST here. Wonderful. Perfect. Okay. But then again, like I said, make sure you also use software composition analysis and either DAST or IDAST. Okay, with that said, do we have any questions? We still have 5 minutes.
Yeah.
So
First
Sarah,
of
do we
all,
have questions?
yeah. First of all, thank you very much, Mira, for the very informative presentation. And yeah, as you already said, now it's the time for our Q&A session. So in case you have questions, please type them in the questions panel in your control panel, and then yeah, we will answer them right away. Throughout the presentation, the first questions already came in, so we'll start with the first one, which is, what role has security played in your DevOps experience?
Mm-hmm. Yeah, I think a huge role, right? When I see all of the challenges that we saw in the industry um, from the last 14 years, right? Whether it is working with the development team in training them, or whether it is building the tools in the pipeline, whether it is triaging all the results, or even like configuring the rules. I think security has played a huge role. I think mainly education, right? Like anyone can do all of the activities, but then educating the entire organization, talking to them about the risk in the way they understand, the way a C-level executive understands versus the way a developer understands. I think that was a huge role that we played, or we even play now within Synopsys, right?
Thank you. So I'm going to go on with the second one, and it's a rerun on a budget. How can we justify this investment?
Yeah, I think that is where I talk about the ROI, right? I think that blog went live either yesterday or day before, right? When your organization hasn't been breached and you want to perform all of these activities, it's hard to justify, right? I need so much budget because the ones who have breached know how dangerous it is, and how bad it is for the organization, right? So, but I think start slowly, right? You can start with one tool, which is commercial, which is good. Automate it in your pipeline. A lot of others start with open source, and then see how things work out, right? Because there has to be a balance. And then more than anything else, you need to look at the risk of your application. Is it an externally facing application? You have a lot of business risk. Then yes, then I think you can easily justify the budget that is needed, because now you have technical risk versus the business risk. Map that and talk to your executives, right?
Okay, great. So far, I have one last question. In case you still have anything for Mira, then now it's the last chance to ask. The last question at the moment would be, how can we implement intelligent orchestration without required expertise and skills in-house?
Yeah. Again, like I said, it's intelligent orchestration is patented, and it is Synopsys, right? So you would need to have Synopsys help you implement intelligent orchestration. And then once it's up and running, then it's up to you, right? Like any other tool that you have within your organization, right? Once you optimize and then see the ROI, then that's it.
Okay. Then thanks a lot, Mira. If there should be any more questions here, feel free to send them in, and we're very happy to. I'm happy to pass them on to Mira. Wait 1 second. I think.
There is this
Okay.
the resources
Now a
page.
last question,
Yeah.
or not a question, came in. One attendee said, "Just a big thank you, Ms. Rao. Unfortunately, I got to go, but yeah, the presentation was very helpful." So I
Yeah.
think this is a nice attendee feedback for you, Mira. And yeah,
Thank you.
you
So
wanted to add something before I
no,
close the webinar?
there is the resources page, and then we also have 2 white papers. And like I said, there is a lot of information on the Synopsys blog about intelligent orchestration. So please go take a look at that. Thank you. Thanks, everyone. Bye.
Thank you, Mira, and yeah, for the presentation and answering all the questions, and of course also to all our participants. Thank you for tuning in into our webinar. We hope you liked it, and we would be very happy if you tune in again in one of our next webinars. And yeah, thank you and goodbye.